Hello. So in this video, we'll be seeing about irrational numbers. So up to now, you know what rational numbers are, what are different types of numbers. So let us focus a bit on what irrational numbers are. As the name says, irrational, the numbers which are not rational are known as irrational numbers. So obviously, whatever are the properties of rational numbers, such properties will not be followed by irrational numbers, right? You know that as per the basic definition of rational numbers, any number that can be represented in the form of p by q, where p and q are integers and q is not equal to 0, are rational numbers. So if I talk about irrational numbers, any number which cannot be represented in the form of p by q, right? Any number which cannot be represented in the form of p by q, where p and q are integers and q is not equal to 0, are known as irrational numbers. You can say this is one of the basic definition of irrational numbers, right? Let me write that for you. Any number which is not rational are irrational numbers. First thing. So now you know that irrational numbers cannot be represented in the form of p by q, first thing. Second thing, you know that rational numbers, what is the decimal representation of rational numbers? Rational numbers are either terminating first, or they may be non-terminating and recurring. Numbers which do not satisfy both this condition come under the category of irrational numbers, right? So I can say that irrational numbers are those numbers which are non-terminating and non-recurring. Such numbers are known as irrational numbers. Let me give you some couple of examples of irrational numbers. First, take the square root of any prime number, for example root 2, root 3, root 5, root 7, etc. Such numbers come under the category of irrational numbers. There is a proof that you can either you can using the division method, you can expand them using decimal expansion, and when you will see, then you will see that the decimal expansion are non-terminating and non-recurring, hence they are classified as irrational numbers. We'll also see in the next video the proof of contradiction, in which you can prove that such numbers are irrational. Other irrational number includes pi, e, etc., etc. Such numbers also come under the category of irrational numbers because they are not rational. Now you might be wondering, say for example 0.25, right? It is a rational number. Why? Because 25 by 100 in the form of p by q, and q is not equal to 0, both are integers, hence this is rational, right? Second category of decimals that we studied is say 0.66666, like this, which can be represented as 0.6 bar. Now tell me whether this is rational or irrational, right? Now you know that irrational numbers are non-terminating and non-recurring, but this is non-terminating and recurring, hence this is rational numbers. And since this is rational, you can represent this in the form of p by q. Let us see how. Let x be equal to 0.66666, right? Then I can say 10x is equal to 6.66666, like this. Subtract both the equations, so 10x minus x gives 9x equals to 6. Therefore x is equal to 6 by 9 or 2 by 3. Okay, in the form of p by q, both are integers and q is not equal to 0, hence 0.6 bar is a rational number. So now I think the definition of irrational numbers is pretty clear. Operations of irrational numbers, etc., we'll be seeing in the other videos, but I just want to focus in this video about the basic definition of irrational numbers, right? A number which is not rational, which cannot be represented in the form of p by q, will come under the category of irrational numbers. Thank you.